Hi, second graders. It's Mrs. Sylvester to do some math review with you today on Tuesday. So I am on our Google Slides, and we are on slide number 33, and we are going to review another word problem together. Hopefully you had some good practice with Mrs. Sodden yesterday on Monday. So let's check out our word problem today. And I know Mrs. Auden said that it's very important to think about what the problem is asking. So we'll pay close attention to any clue words and also be thinking about the numbers that are in the problem. What are they? Are they add-ins or are they the total? And what is our unknown? So good readers, together with me or follow along. Caleb and Noah picked up 70 leaves in their backyard. Out of all of their leaves, 47 of them were red leaves and the rest were brown. How many brown leaves did Caleb and Noah pick up? So I know that sometimes when I'm solving a word problem, I read it once to just kind of understand what is going on. And now I like to go back and reread and either if I had paper and wrote this word problem down, I like to box my numbers and underline any clue words. But since I don't have that printed, I'm just going to use my blank piece of paper, or in my case, my board here. So let me reread and now really think about what I know. I clearly see the question is asking me, how many brown leaves did the two boys pick up? And it looks like even though there are two boys, they're working together as a team. When I was reading it, I thought, oh, am I going to be comparing how many leaves Caleb and Noah picked up? But as I reread, no. So I know sometimes in our word problems we have two names of two different people, but I don't see any of those, that clue word that we're comparing, like more than or fewer than. So instead, we just have two boys' names, but they're working as a team. So let me reread and make some math work to explain and show my thinking. Caleb and Noah picked up 70 leaves in their backyard. Out of all of their leaves, 47 of them were red leaves and the rest were brown. How many brown leaves did Caleb and Noah pick up? And my students know that I like to use my body to model a math mountain. So as I read that the second time, I was thinking in my head, and now let me act it out with my math mountain body. Caleb and Noah picked up 70 leaves in their backyard. Out of all of their leaves, 43 of them were red leaves, and the rest were brown. How many brown leaves did Caleb and Noah pick up? So if you remember all the different types of word problems we learned that you can add to or take apart. And so this word problem, I already know my total. Together, Caleb and Noah picked up 70 leaves, but I'm going to take them apart and almost like sorting them into a group of red leaves and a group of brown leaves. And of course, those two groups, those two different color leaves, are my two add-ins. And as I made my math mountain, I could go back and reread the problem and double check again that I have modeled my math mountain correctly, but I will do that now on my paper or board. And I'm going to reread it again. You can never reread word problems enough to make sure that you didn't miss any clue words or misunderstand what the problem was saying. So Caleb and Noah picked up 70 leaves. So I'm very sure that that is my total. That goes up the top. Out of all of their leaves, 43 of them were red and the rest were brown. So that word rest, that is a clue that that is the unknown. And our question connects with that. It could have been worded, how many of the leaves were brown, or how many brown leaves did Caleb and Noah pick up? And we know also that when we use our math tool of the Math Mountain, it's a good idea to put in our operations or our adding sign and subtraction sign. So because the two parts at the bottom of the Math Mountain are the add-ins, I'm using my addition symbol, and I know that our Math Mountain relates addition and subtraction, so my total can subtract my add-in. I could subtract on this side too, but that's where my unknown add-in is. So now that I have my math mountain, I can connect it or relate it to an equation. Some friends have solved this problem or a problem like this by adding up. You might, in your head or on your work, think, okay, 43 plus what would make that nice 10 of 70? And if you want, you can show your place value lines. It's nice that the total is a 10, 7 tens, that you can make a 10. So that would be one strategy. Or we know, again, our math mountain, we can take our total since we know it and subtract the add-in that we know. So another equation to solve this word problem would be 70 minus 43. And since I wrote both equations, I could solve both, and that way I could double check. So I know in my head that 40 plus 30 would make 70. But if I add 30, 40 plus 30, I'm not going to get 70, I'm going to get 73. So I actually don't want to add 3 tens. Instead, I want to make my 7th 10 or a new 10 with my ones first. So 3 and what would make a new 10? 3 and 7 would make a new 10. And since I'm adding, I put my new 10 here. And with that new 10 and my 4 tens from 43, I already have 5 tens, so I don't need 3 more tens to make 70. I only need 2 more tens. So that's one strategy that some friends really like. I've seen friends do it more in their head, or they think, again, just about making the 10 with the ones, and then almost like subtracting. So when I first said, oh, 40 and 30 is 70, since I have 43, I would need 3 less than 30, and 3 less than 30 is 27. Don't forget our great strategy of using our place value quick picture or proof drawing. That's another strategy that a lot of friends like when they add up. So I'm going to draw 43, 10, 20, 30, 40, freeze. I'm freezing so I can now show my ones, right? 40 is my 4 tens and 3 ones. 1, 2, 3. And I usually draw my ones horizontally, but if I'm adding up, I like to do it vertically to show that I'm making a new 10. So 3 ones, and I'm going to draw a little line here knowing that now I'm counting on or adding up, and that will help me know my new add-in or my unknown add-in. So 3, 4, 5, 6, 7, 8, 9, 10. So I just made a new 10 by adding 2 and 5 makes 7 more ones. And so I now have 50, 10, 20, 30, 40, and this is my new 10, 50. And if I want to make 70, I know that I would add 2 more 10s. So what did I add on? I added my 7 ones and then 2 more 10s. So that can also be a way to connect with your equation for adding on. Now I think that a lot of friends, since we've gotten so proficient at subtracting, and we know that our math mountain relates our addition and subtraction, many friends, when they would see a word problem and a math mountain like this, instead of adding on, our brains have gotten really used to subtracting from the total if we're looking for the unknown add-in. So let me come down here and subtract. I know that understanding our place value, we want to make sure that we subtract our ones first. So first subtract ones. 0 ones minus 3 ones. What's our rhyme we say? More on the floor, go next door to get 10 more. So I don't have any ones in 70. I have my 7 tens. So I need to ungroup one of the tens, which means I'll just have 6 now. And that 10 becomes 10 ones. Some friends like the strategy of just showing your 10 is now 10 and your 0 ones, or you can cross it out completely and rewrite that you now have 10 ones. This method, our ungrouping, can also be supported with our proof drawing. If I draw 70, 10, 20, 30, 40, 50, 60, 70, and I'm taking away 43. I don't have any ones, so I cannot take away 3 ones. So this 10, I'm going to ungroup into my 10 ones. So that just supports what I did on my equation. One of my 10s was ungrouped into 10 ones. So now in my picture, how many 10s do I have left? 1 10, 2 10s, 3, 4, 5, 6 10s. So that's why I only have 6 10s instead of 7 10s. And now I have 10 ones. We know that 6 10s and 10 ones is still the same as 70, but I'm able to subtract now in my ones place. So 10 ones minus 3 ones, that's 10's partner, so I know I have 7. You can use your quick pick if you need support. Let me take away 3 ones. 1, 2, 3. I know I have 7 ones left. Next, I subtract my 10s. 6 10s minus 4 10s. 1 10, 2 10s, 3 10s, 4 10s. I have 2 10s left. 6 10s minus 4 10s is 2 10s. So my unknown add-in is 27, and I took time to really show 3 different methods, and each time I found that the unknown add-in was 27. You can choose one method, but of course, double checking, and if you have any family members who can solve this too and explain their math brain, we love having math talks in 2nd grade. Not just saying, oh, did you get 27? I got 27, but really going through and explaining your math brain. So great job reviewing our word problem. You could come up with your own word problem. This problem was about leaves in the backyard, but maybe you can think about how many flowers you could see in the backyard and try reviewing different word problems, not just an unknown add-in, but an unknown total. Moving on to your next slide in our Google Slides, on slide number 34, you're going to review your place value, and this is kind of fun. It's almost like a riddle to think about what number you're thinking of. And we played this game with our scrambled secret code cards. So that could be something fun you could do at home also. In my classroom, we like to take number cubes, also known as dice, and say that 1, we're going to roll for the hundreds place, and a second, we're going to roll for the ones place, and then a third, we're going to roll for the tens place, and then write them down and unscramble them just like this problem is doing. And then you have a little clock review, but I'm going to jump down now to slide 35. This is a review of adding 3 add-ins, which really is not hard. We did it way back in the beginning of the year, but let's just look at a quick method, and maybe you know how you would do it in your own way also. So this paper, this slide is having the add-ins horizontal, a horizontal equation. And what were our strategies we shared for when you have 3 and then even 4 add-ins, although there aren't any on this page. One strategy is to find 10's partners. So can you, we're going to put one strategy is, can you make a 10? Can you make a 10 in this one? I can. I see that 7 and 3 make a 10. And one way to show this is circling the 2 add-ins that you're going to add first. So I know that 7 and 3 make a 10. You don't have to show that math mountain of making a 10. You might just want to circle. Some friends maybe want to do a little cross off on that number, but then you can easily see, okay, once you've made a 10, now you have a teen total to make. 10 and 5 make 15. Now, not every problem will necessarily have add-ins that make a 10. So what would be another strategy? Well, sometimes if you maybe aren't as fluent with your math facts yet, you at least know your doubles. So if you have an equation and you can find a doubles, that can also be a quick way. So if I had, for example, 4 plus 6